So section 5.4, we're looking at length and area. Now, what we need to know, first of all, is if you've got 2 points, the distance between them is the length of the line segment that's between them. And that we can do by Pythagoras Theorem. So this here is the change in y, this here is the change in x, and then square this, add them together and square root it. Now, if you write that down algebraically, well, this change in y, well, if this one here we're labelling x2, y2, and this one here we're labelling x1, y1, then this change in y is y2 minus y1. And this one here is x2 minus x1. So the change in y, change in x. So, sorry, I've done it as though I'm finding the gradient, haven't I? So change in y, that's that distance. Square it, add it to that distance squared. If you square root that, you'll find the length of this hypotenuse of the right angle triangle by Pythagoras Theorem. So that's where the formula comes from at the start of section 5.4, and I'm sure you've seen that before. Now, area. The tricky bit here is that all I can do is give you some general remarks, and the first one is practice, get plenty of practice in. When you're trying these questions, at some point most A-level students get stuck. Now, if you don't get stuck with this chapter, lucky old you, well done. That's going to help you out. But most people at some point are going to get stuck. And where they get stuck is with some of these area questions. Now, don't go for solution banks. Don't ask for help too soon. That process of getting stuck should be where the information is getting into your long-term memory. And it seems pretty unpleasant at the time. You're sitting there thinking, well, I can't do it. I'm stuck. I'm not getting anywhere. Just stick with it. Try things. Put an effort in. Put a lot of time into it. And stop and struggle. As long as you eventually solve the problem, or go through it with a teacher, or eventually go through it with somebody else, then that time struggling will have helped. From what I've read about how learning works, it should have helped your long-term memory, it should have helped your brain develop the sort of pathways for how to solve similar sorts of puzzles in the future. If you get stuck and too quickly ask for help, and just get someone else to show you how to do it, or dive into a solution bank, then you're not doing that struggle, and you're not getting your brain to try and make those pathways for solving similar kinds of puzzles, okay? So the help I can offer you, first of all, is if you are getting stuck with this or any other A-level content, and you're going through that problem of I've been on this question half an hour and I can't see what to do, it might feel like the end of the world, it might feel grim and horrible, but actually, in the long run, there's some really good learning happening there, as long as eventually you understand where the answer comes from. If you don't personally find it in the end, that's not necessarily the biggest problem. It's obviously the best way, but it's not necessarily the biggest problem. What can be a big problem is if you ask for help too soon without having got properly stuck. So if you just look at it, go, I don't know what to do, and then go straight to your teacher, that's not necessarily helping. If you look at it, try it, go back to the next day, spend a few more minutes on it, get stuck, and then ask your teacher or ask someone else to help you, that's really good learning. Secondly, or is it secondly? Thirdly, I don't know how many points I've made. If you're looking at the area questions, they almost always tend to work something like this. We've got a y-axis and an x-axis, and I draw a line here, and I draw another line here, and it'll say something like, well, so here's a triangle. Look, I've made a triangle between these two lines in the x-axis. Find the area of that triangle. Now, at this stage in the book, we've only got one formula for the area of a triangle, which is base times height and half it. Later on in the book, and from GCSE, you may remember that area equals 1/2 AB sine C, and we may need to worry about that when we come to exam paper questions and past paper practice and things. But for the moment, all the ones in chapter 5, this is the only thing we've got. Now, if that's the only thing we've got, that means that we need to be able to find the base and the height of this triangle. And the base and the height have to be at 90 degrees. So it might be that this here is a 90-degree angle, and all I've got to do is find the distance from here to here and the distance from here to here. It might be that this is not a 90-degree angle and then being hard with this, in which case I can find the distance from there to there, that will count as the base, and then I need to find the distance from this point here down to the x-axis. Well, in this case I can do that because the y-coordinate of this point is the height of the triangle, isn't it? So draw a diagram. I'm sure whoever your maths teacher is, by this point in this chapter, they have said draw a diagram a few hundred times. Well, let me say it again, draw yourself a diagram, picture what's going on. If you're asked for the area of a triangle, it's almost always a triangle or a shape made out of triangles. If you're asked for that area, you need a base and a height which are at 90 degrees. So look for where the 90-degree angles could be. Maybe you can check whether the two lines are at 90 degrees. If all else fails, you can always find the length of one of the sides and the distance from that point there to this line here. There's always going to be a way of doing it. It's not always going to be a simple way, but there's going to be something there. Look out for isosceles triangles, equilateral triangles, any geometrical clues that you might have that might help you. Other than that, there isn't much I can add. It is just a case of looking at the information in front of you, building it up. If you're getting stuck on some of these questions, make sure you've done the earlier parts of the chapter well. I think that's about the 4th or 5th time I've said that in one of these videos on this playlist, so I'm not going to stress that point again. But make sure you're building the chapter up stage by stage. I'm going to go straight on section 5.5 in this video as well, because again, there's not much I can say about this other than general advice. I've talked about the general advice for modelling kind of questions a little bit in the quadratics chapter, so if you watch that you might want to just stop the video here, but really modelling, as far as we're concerned, it's a really important mathematical idea. We talk about it more in the statistics and mechanics part of the course. For now though, we're going to think of a modelling as an in-context kind of a question. There's not a huge amount that we can say in a video like this. It's really about you looking at the sort of questions they ask you and applying yourself to those questions. There is a little reminder here that a proportional situation would look like this. Y is proportional to x, we would write as this, y proportional symbol x, y is proportional to x, and that means y equals a constant times x, and if we drew that as a straight line graph, it would be a straight line going through the origin. So if you know y is proportional to x, it is a straight line like that, and therefore we can apply all the operators, all the apparatus of straight line graph maths to those sorts of situations. Other than that, elsewhere we talk about what models are and how, you know, it's maths and real life and linking those two things together. I think the start of the mechanics course is where I talk about that in depth if you're looking for my version of it. The start of the year 12 mechanics course, the first chapter of that certainly. And like the quadratics modelling section, this is take the information you've got from the chapter 5, apply it to real life situations, so you can think about it as an applied question based on the maths that we've got here. There's no extra information I can give you, just use the information you've got and stick it all together. That's often the case with A-level, that's where the difficult bits come in. Use the information you've got and stick it all together is often the difference between a nice easy question and a hard question. In an easy question, there's only one or two things you need to do. In a hard question, you need to take 3 or 4 bits of information from lots of different places. The answer is always start with the easy questions, build up stage by stage into the harder questions. That's chapter 5 dealt with.